So check from the board whether you can see what is there. Now we take a question from May 2018, question 1C, Advanced Financial Management, and this is decision trees. Net present values and expected net present values using decision trees. So if you have the paper, you can take it out. I've said it's May 2018, question 1C, May 2018, question 1C, Advanced Financial Management. Now I read the question, then I project it before we start the solution. So you're told Tabi Limited has a potential investment opportunity for which the initial cash outlay and future cash flows are uncertain. The analysis I've carried out provided the following probabilities. You are given probabilities for cash outlay as well as the cash outlay. Then you are given annual cash inflows, the probabilities of annual cash inflows and their respective amounts. Additional information. Number one, the cost of capital is 10%. Number two, life of the project is expected to be 10 years and the salvage value is 0. Required. Construct and decision tree for the investment to show payoffs, probabilities, and net present value for each alternative 6 months. Number two, the expected net present value of the project. Now this is my decision tree and these are my workings. Now before I explain, let me show you the question, how it looks like. Is it legible or not? It should be legible. It should be legible. You are told, now read. The student, you are the one to read. You have the question?
Yes.
Yeah, you can read the question.
Tabi Limited has a potential investment opportunity for which the initial cash
Are the others getting?
outlay.
Are the others? Can others hear you?
Yes.
Your voice is very low. You can read.
And future cash.
Tabi, study Tabi.
Tabi Limited has a potential investment opportunity for which the initial cash outlay and future cash flows are uncertain. The analysis carried out provided the following probability estimates. Probability estimates cash outlay and annual cash inflows. Probability amount, 0.4, 0.25, 0.25 and 0.1. Additional information. The cost of capital is 10%. Life of the project is expected to be 10 years. The salvage value is 0. Required. Construct a decision tree for the investment to show payoffs, probabilities, and Enpv for each alternative. Number 2, expected Enpv of the project.
So we are taking up to required number 2. So that is the question as it appears there. Okay, let's have the solution very fast. It's quite simple. So the first thing you are given is probabilities associated with cash outlay. Now the probabilities you have 0.4, 0.25, 0.25 again, and 0.1. Remember, this must total to 1. That is 0.4 plus 0.25 plus 0.25 plus 0.1 should give you 1. So those are the probabilities associated with the respective cash outlay. Now cash outlay or cash outlays which are associated with those respective probabilities are given at 250 million, 280 million, 300 million, and 305 million. So what you do is that you start your decision tree. This is a decision tree. You start with a node. This is called a node. Now here, because there are four probabilities associated with each cash outlay, then it means you should have four branches for each probability. There are four branches for each probability associated with each cash outlay. Is it? Yeah, so you should have understood that. Now, once you have those four branches, the next thing, you just need to write those initial cash outlay, then together with their respective probabilities. That's the starting point. Right. So this is to do with cash. This is to do with cash outlay. It's important to know that. This part, you can see that part there. That part there. This part is to do with initial cash outlay. Now remember how you calculate net present value. How do you calculate net present value? We usually say, remind me. Net
present values minus initial capital.
Total present values minus
Initial capital.
initial capital outlay, or the amount. In this case, what we have is annual. These cash flows are constant. Are they constant? Are the cash flows constant? Are they constant? They should be constant because this project is for 10 years. The 10 years. So if it is 45 million, for example, it is constant for 10 years. 45, 45, 45, 45, 10 years. If you come to 50 million, that figure is constant for 10 years. So for us to calculate net present value for cash flows which are constant, you take that annuity times what? Present value annuity factor minus what? Initial capital outlay. Now let me write here. Let me fix it here. I'll say annuity times what? Present value annuity factor. Now here we have 10%. We are told cost of capital is 10%. Then 10 years minus initial capital outlay. So note here, because we are given 10 years, this project has expected life of 10 years. And the interest rate is 10 years.
10%.
Yeah, 10%. I want to see whether you are listening. Right. If Okoranga is still okay. Now, 10%, 10 years. You read from the table, the second table, the annuity. This part, you may be given a rate which is not in the table. So you should be able to calculate these annuity factors if that percentage is not in the table. So you have illustrated here. You say 1 minus into brackets 1 plus r raised to negative n over r. Like for example here, if you read 10% and 10 from the table, you get 6.1446. So you said 1 minus 1 plus rate, which is 0.1 or 10% raised to negative 10, the total number of years, divided by r, which is 10 or 0.1, you get 6.1446. That's where you'll be getting this number there as we continue illustrating. So we are trying to say that what we are calculating here is net present values, which is calculated by the annuity. The annuity here is to do with the cash flow that the project is generating. So if, for example, you take the first part, you can see here 45 million is being generated. That's the cash flow, but it is generated for 10 years. 50 million is generated for 10 years. All these figures, these are cash inflows. with their respective associated probabilities. So for example, if you go to part 1, that's where you'll find we'll be taking 45. 45 is the annuity. You multiply by present value annual factor, 10%, 10 years. If you read from the table, the second table, not the first one. The second table is the one for annuities. 10%, 10 years, you get 6.1446, which is also calculated as 1 minus into brackets 1 plus r, close the brackets, raised to negative n over rate. You still arrive at the same answer. So 45 times present value annual factor minus initial capital outlay, which is here, the 45. This is the initial capital outlay. Okay, before I come back to the illustration of what I'm doing there, let me explain something else which I've omitted. So I'm saying that this is a decision tree whereby the first part from here, you can see you started with this node, have the initial capital outlay, this part now, this initial capital outlay, because you cannot calculate net present value without the initial capital outlay. Now you start with the initial capital outlays together with their respective what? Probabilities. Right? Then ask yourself how many probabilities have you been given. So the total number of probabilities will help you to establish how many branches are there in your decision tree. If you are given 2 probabilities, it means you have only 2 branches. If there are 3, there are 3 branches. Now, if the probabilities have not been given and there are 2 branches, you can assume that the weights are equal. So you can use 0.5, 0.5. If there are 3 branches and there are no probabilities, you assume there are 3 branches. 1 over 3, 1 over 3, 1 over 3. If there are 4 branches and there are no probabilities, you assume these probabilities are same, 0.25, 0.25, etc., etc. But here, in this question, the probabilities have been provided. So we are given the initial capital outlay, 250, 280, 300, 305, with their respective probabilities, 0.4, 0.25, 0.25, 0.1. Now from there, you go to the next part now. We have explained this part, how we have explained this. This is to do with cash outlay, initial cash outlay. So the first part of your decision tree will be something like this. Then you go to the next part now, which is associated with, so I have explained this, the initial capital outlay. That portion which you'll be deducting. Then the other part is to do with what? Initial, not initial, cash inflow. Cash inflow, this part now, which is associated with this part, the expected cash inflows together with their respective probabilities. Now let me present it again. You may have not seen that one. Let me present that one again. Refresh from your. Now what I've explained from the other side, you can see cash outlay 250, 280, 300, 305. Their respective probabilities 0.40, 0.25, 0.25, 0.10. That's the first part. You can see what we have done here. Here, this portion here, we have elaborated that. Now I want to elaborate the other part for cash inflow. The cash inflow, the cash inflow is here. Cash inflows are there. Annual cash inflows with their respective probabilities 0.20, 0.40, 0.40 again, amounts 45, 50, 60. Okay, those are annual cash inflows with their respective probabilities. So move on. Move on to this part here. So what you do now, the probabilities have been given. You can see 0 0.2, 0 0.4, 0 0.4. That totals to 1. So that's the first branch. This first branch here, we have 3 more branches. And these are the expected cash inflows: 45 million, 50 million, 60 million. That's the first branch. Go to the second branch, which has the initial capital outlay of 280. The same branches, they are 3: 0 0.2, 0 0.4, 0 0.4. The same is the first branch here is the same as, in terms of the numbers, you can see 0 0.2, 45, 0 0.4, 50, 0 0.4, 60. When you come to the second branch, which has 3 branches, is the same figures: 0 0.2, 0 0.4, 0 0.4. 0 is the same as what you have in, above. You can see here is the 45, 50, 60. 45, 60, 50. The same repeats the same: 0 0.2, 0 0.4, 0 0.4. 45, 50, 60. The same. The third one, 0 0.2, 0 0.4, 0 0.4. The same figures: 45, 50, 60. Have you realized that? Yeah. So these ones don't change. They are the same. The only change will arrive because here the initial capital outlays are different. They are not the same. So once you have that, now that is your decision tree. That is how your decision tree will look like. That is how your decision tree will look like. I want to get our net present values and our expected net present values. So part 1, this is my part 1. Part 1, my net present value, because you have said net present value is calculated by annuity times present value annual factor minus initial capital outlay. My path will be first path. This is my first path. That's what you can see I've written here. Part 1. 45, which is here, times present value annual factor. That means 10%, 10 years is 6.1446. So 45 million times 6.1446 minus initial capital outlay. The initial capital outlay for part 1 is 250 million. You minus that. So 45, which is the annuity. You see, this 45 is generated for 10 years. 45, 45, 45, 45, 45 for 10 years. So it is an annuity. It's what we are calling A here. So like 45, you multiply by present value annual factor at 10%, 10 years, which is 6.1446, minus initial capital outlay, 250 million. If you follow that path, part 1, the initial capital outlay for part 1 is 250 million. Is 250 million. You go to part 2. Now before that, the net present value will be 26.51. That is 45 times 6.1446 minus 250. You get 26.51. That is the net present value. But we are required to show the expected net present value. Expected net present value, we are supposed to multiply net present value by joint probabilities. Already I have my net present value here, 26.51. So I need to establish my joint probability by following part 1. So my part 1, my probability is 0.2 times what? 0.4. That's the joint probability for these cash flows and the expected initial capital outlay. So I'll take 0.4 times 0.2. That is where this one is coming from. That's the joint probability. So the expected net present value, I will pick 26.51 times 0.8, and my answer will be 21.21. So that is where I got that number from. That is my expected net present value for part one. For part one, you will follow part one. The same applies to part two. Part two, you take 50 times present value annual factor, which is 6.1446. Now this one now remains the same throughout. 6.1446 as far as these workings are concerned. 6.1446 remains the same throughout. So I'll be multiplying by that number throughout. Only the cash inflows, I'll be picking the cash inflows. I multiply by 6.1446 throughout. I'll explain how we have gotten that from the table. And also I've also shown here. And then I minus the initial capital outlay on this side. Okay, so part one, we're okay. When you go to part two, I'll take 50 million, which is the cash inflow, expected cash inflow. I'll multiply by 6.1446 minus 50 million. We are still in part one. So you minus 50 million, you get 57.23. Then joint probability is 0.4 times 0.4. 0.4 times 0.4. I will get 0.16. What is my expected net present value? I just multiply 57.23 times 0.16. I get 9.16. I go to part 3. Part 3. I will take, now this is my part 3. You are okay with that? With that. Part 3, 60 million times 6.1446 minus initial capital outlay of 250, and I will get 1 is 118.68. Then joint probability 0.4 times 0.4. 0.4 times 0.4, I get 0.16. Then expected NPV, it will be 118.68 times 0.16, I get 18.99. So those are the workings for part one. Now note this, check here. Now you have to check here. When you are through with part one, when you go to part two, what changes? Can you guess what changes when you go to part two? Yes, obviously. So you have to know that. You can see here for part one, we are minusing initial capital outlay of 250. So we are through with this particular part. We are through with that particular part. So we are coming to this second part now, the fourth part, which has initial capital outlay of 280. So the cash flows now, the expected cash inflows also remain the same. Is a repetition of the cash flows, the cash inflows and their respective probabilities is a repetition of what you have done up there. They just repeat themselves, okay? They don't change. These ones, check here. You have to understand this one now. You see what you have done there, those three. When you come to the second part now, you can see how I have divided these workings. This one, I mean, you are through with the first part. You go to the second part where you have 4, 5, 6. In that, here, you repeat the same. This part will be the same thing. It's like pasting. You can see 0.2, 0.4, 0.4. 0.2, 0.4, 0.4.
But the probability changes.
The probability.
0.25.
Probabilities.
Yes.
0.4. Here, I'm saying this part.
Oh.
This part alone. This part is the one which will change for joint.
Yes.
Joint probabilities will change. Joint probabilities will change. But here, this part is the same as what we have above. Is a repetition. Okay, so let's go to part 4. What will you say? Cash inflow 45. You can see this 45 is the same as the one you have there. So 45 times what? 6.1446 minus initial capital outlay. Now this one has to change. You not use 250. You can see this part is coming this way. Your part is coming this way. So initial capital outlay is 280, not 250. So 45 times 6.1446 minus 280, we got negative 3.49. Joint probability, where is the joint probability? 0.2 times 0.25. So that one changes now. You get 0.05 multiply negative 3.45 times 0.05. You got that 0.175. Go to part 5. Part 5 we are doing part 4. Part 5, give me part 5. 50 times 6.1446 minus 280. The same 280. You get 27.23. Joint probability is 0.4 times 0.25. 0.4 times 0.25, you get 0.1. 0.1 times 27.23, you get 2.72. Go to part 6. Part 6 is here, this one. 60 times 6.1446 minus initial capital outlay of 280, you get 88.68. Then joint probability for part 6, 0.4 times 0.25, you get 0.1 again. Then you multiply 0.1 times 88.68, we get 8.87. Now, read for me part 7. Give me part 7.
You take 45, multiply by 6.1146.
1146. 1146.
1446.
1446.
You subtract 300,000.
300,000. You get negative
23.49.
Yeah, so note that. You can see how I have divided these workings. We are here. We are in different parts. Remember, these ones you just repeat themselves. So when you go to part 7, what has changed? I want you to note 300,000 has changed. The initial capital outlay. We are not using 280 because the last time we used 280 is this part here, the sixth part. You see it is coming all the way to 280. When you come to this part, the initial capital outlay goes to 300. Yes, that is where you are lessing 300. So 45 times 6.1446 minus 300, you get negative 23.49. Joint probabilities 0.2. Yeah, here 0.2 times 0.25. Okay, so 0.05 times negative 23.49, we get 1.175. Read number 8, part 8.
50 times 6.1446 minus 300.
You get 7.23. Joint probability
0.4 times 0.25.
you get 0.1. And then you get 7.23 times
0.1.
you get 0.772. That is what expected NPV. Okay, number 9, when you go to part 9, now we are in this part now. We take 60 million, this is my cash flow, cash inflow, 60 million times 6.1446 minus initial capital outlay minus 300. You get 68.68. Joint probability 0.4 times 0.25, you get 0.1. 0.1 times 0.1 times 68.68, we get 6.87. Now we go to the last part now. The last part in terms of cash outlay, and also that is also the last part in terms of the cash inflows. So what we change here is the initial capital outlay. We are spending 305. So the 10-year path, 45 million times 6.1446 minus 305. We got 28.29. We got 28.29. Joint probability 0.2 times 0.10. We get 0.02. 0.02 times 28.49, we got 0.57. That is path 10. Path 11, 50 million times 6.1446 minus 300. You might,
305.
yeah, 305. 305. 305. Which part? 11. 11, yeah. 50. Is this 50 then? 50 times 6.1446 minus 305, the initial capital outlay. We get 2.23. Joint probability 0.4 times 0.1. We get 0.04. Okay. 2.23 times 0.04, we get 0.09. Is it possible to see what is on the other side? You can see. Okay. It is legible. Then it's okay. Then the last part is part 12. Part 12, we are taking 50, but 60 million times 6.1446 minus initial capital outlay of 305. You get 63.67. It is legible. It's legible.
It is okay.
It's legible.
When I put it on
Yeah. When you put it down, you will not be able to read from the top. Yeah. Now, so the last part, 60 million times 6.1446 minus 305, you get 63.67. Joint probability, 0.4 times 0.1, you get 0.04. 63.67 times 0.04, you get 2.55. So these figures, you can see how we have calculated them. All these figures, this is a total expected NPV. So these expected NPVs, the workings are here. These are the workings for those numbers there. And we sum them together. If we sum them together, you get 70.4. That is the expected NPV. My expected NPV is 7.4. Did you get that as your answer? So you can mark for yourself. If you got it right, you give yourself right. And you be fair when you are marking for yourself. But you told me you got 769. So
69.27.
So you can give an excuse of rounding off. Okay, so that's basically how we go about it. So you are told to construct a decision tree for the investment to show payoffs, probabilities, and net present values for each alternative. So this is your decision tree. Should look something like that. So remember, this pattern is for cash what? Cash outlay. That is something you should know. Part of your decision tree, especially in FM, part of your decision tree in your FM should comprise of what? Cash outlay together with the expected or respective probabilities. That one you must know somewhere in your mind. You should be given initial capital outlay, not one figure, several of them, together with their respected probabilities, okay? This part. So identify how many probabilities have you been given and how many figures associated with initial capital outlay have you been given. So those determine the number of branches, the branches that you use. So if you are told the probability is 0.5 and the other one is 0.5, it means what? You have two branches. But here, how many probabilities have you been given? 4. You have 0.4, 0.25, 0.25 again, and 0.1. So that means that when you start from the node, the first node is where your decision tree starts. The decision tree should have four branches. Each branch is associated with a certain probability, and each probability is associated with a certain initial capital outlay. That's the first thing. Then, once you have been given initial capital outlay together with their respective probabilities, the other thing is to establish the expected cash inflows. You must be given the expected cash inflows, that is, together with the respective probabilities. So they will be originating from where you see these branches. Can you note something here before you forget what you are doing? Realize that your decision tree starts from this particular node, and there are 4 branches. This branch, the first branch or the first line will stop at a node, this sort of a node. Now, once so, it means you have 4 nodes, because wherever where this particular line ends, you put a node. You put a node, okay? Now, once you put a node, originate three what? 3 branches, 3 branches, depending on how many probabilities have you been provided with. Okay. Now, because there are 4 nodes, what does it imply? If in each node there is 3 branches originating from there, it means there will be 12 in total. You have seen how these numbers are repeating themselves, okay? Out of each node. So when you finish up with this node, you go to the second node, it is the same figures which are being repeated here. Have you understood?
Yes.
Yeah. When you finish up with these 3, you come here. Whatever information is there is the same which is appearing here. You are through with that. The same information appearing here. Then after that, because it is expected net present value, we know how to calculate net present value. Annuities, if the amounts are constant, that annuity times what? Present value annuity factor, you minus initial capital outlay. But note this, for expected net present value, remember to multiply your net present value by joint probabilities. So they were asking to construct a decision tree for the investment to show payoffs, probabilities, and net present value for each alternative. So this is your decision tree. You have also shown the net present value for each alternative. The net present values for each alternative are here: 26, 57, 118, negative. So where there is negative, you usually say that you advise the project to be rejected. If net present value is positive, we usually advise the project to be accepted or undertaken. If the net present value is negative, advise the project to be done what? Why? Can you explain as a financial expert? Why are you advised to reject a project which has a negative net present value? Simply because it will reduce the total wealth of that particular business entity. So negative net present value implies the wealth for that entity will reduce. But a positive net present value, what does it mean? The wealth of that particular business entity will increase. I think in FM, you learn something known as what are the objectives of what? Remind me, what were we studying? I've a little bit forgotten. There's somewhere where you say objectives of something. One of them you said is maximization of the wealth of a company. Another one, profit maximization. What were those? If you can remember. That was FM. It is also done in ATD. Objectives of our farm. Objectives of our farm. One objective of our farm is to maximize what? The wealth. The wealth. So, if the NPV is negative, then that project has to be rejected. Because if you initiate that project, the wealth for the farm will reduce. If it is positive, accept, because the wealth of the farm will increase. Okay. So that is it about that part. So we have answered that on decision tree. I've shown you how it is presented, and then they were saying construct a decision tree for the investment to show payoffs, probabilities, and net present value for each alternative. Then the expected net present value of the project. So the entire project now. We sum up all this part here, whereby we are taking net present value times joint probabilities, and you got those figures there. So you sum all of them, and then you have your answer. You have your answer. Anything else from there? Any question? Any question? I think you have understood well, isn't it? So you don't need anything else concerning decision trees. Now check this. Let me give you this as an assignment. April 2022. Check this. You have April. Just check now. April 2022 question. April 2022 question 2B. Question 2B. Check whether it is a question that you can attempt. April 2022. April 2022. You see it? Okay. April 2022. Question 2B.
This one is for portfolio analysis, not decision.
Portfolio. Also, we are giving the wrong and the wrong. So it's not this part. It's not this question. So we are lost.
That's the expected return of salary.
The expected return, correlation, comment. So that was not the right question. Yeah, I'll give you the right question. Now let me get you a different question. I'll give you a different question as an assignment next lesson. So we are through with that discussion. Let me give you my number here. My number is 0727 87 10 93. 0727 87 10 93. So remember to subscribe, like the video, and make a comment. So meet next time.